IPv6 and IPv4. When deploying applications to the Internet computer, HTTPS outcalls can be made to APIs hosted on servers with either IPv6 or IPv4 addresses. The connection method is determined by a fallback mechanism designed for maximum reliability. Direct connection, IPv6. The system first attempts to connect directly from the IC replicas. This is the ideal path for IPv6-enabled services. Proxied connection, fallback if the direct connection fails for any reason, e.g., the server is IPv4 only, or a firewall is blocking the direct connection, the system automatically retries the request through a SOCKS proxy. To see which connection method might be used for a specific service, you can check if its domain supports IPv6 using a tool such as https://ready.chair6.net/. HTTP GET. To demonstrate how to use the HTTPS GET outcall, open the ICP Ninja Daily Planner example, which uses HTTPS outcalls to retrieve an on this day fact. In the project's backend app.mo file, the HTTPS outcall is defined through the following lines. The code above is annotated with detailed notes and explanations. Take a moment to read through the code's content and annotations to fully understand the code's functionality. A few important points to note are, all methods that include HTTPS outcalls must be update calls because they go through consensus, even if the HTTPS outcall is a GET. The code above adds 20,949,972,000 cycles. This is typically enough for GET requests, but this may need to change depending on your use case. The transform function. The transform function in the code above is important because it takes the raw content and transforms it into a raw HTTP payload. This step sets the payload's headers, which include the content security policy and strict transport security headers. When developing locally, this function doesn't have much of an effect since only the local replica, one node, is making the call. When HTTPS calls are used on the mainnet, a common error message may appear that indicates not all replicas on the subnet get the same response. Reject text. Canister HTTP responses were different across replicas, and no consensus was reached. This error occurs when the replicas on the subnet don't all return the same value for a piece of data within the HTTPS response. For example, if you have an application that sends an HTTPS request to the Coinbase API for the current price of a token, due to latency the replicas will not all return the same response. To remedy this, you can request the token price for a specific timestamp to assure that the replicas all return the same response. Calling the HTTP GET request. Click Deploy within the ICP Ninja code editor to deploy the project. Then open the project's front-end URL and click Get Data from the Internet to call the backend canister's HTTPS outcall method fetch and store on this day.